This is a Research Infrastructure Services instructional video.
Um, each shell has its own syntax, but they all support the typical programming structures, the more complex programming structures like loops and conditionals. The shell scripts can be powerful enough that they can be basically become their own new command that you can utilize. And here we have an example of a shell script that's been written. We're using bash as the programming structure in this case. And then the echo command just is a print this line to the print this text to the screen. And so in this case, we're echoing a bunch of text that we've written up. And then at the last is the date command, which just lists the current date, time and date. So when you save that within the, you can edit that and then save that within a text editor, and then later on execute that. So a bit about text editors. They're used to write and edit shell. You can use them to write and edit shell and bash scripts as well as other files. There's many different types of text editors. There's ones that are built into the command line, and then there's others that are GUI based. A few of the text editors that a lot of people use are V or Vim, Emacs, and Gedit. Text editors that are command line based are often tricky to learn because you have to have a knowledge of all the commands that they use within them to get around within the file to edit the text. And so a GUI text editor can be useful for the beginning user. One thing to note is if you're editing files on a Windows machine and you're transferring it to the HPC environment, you'll oftentimes get formatting errors. This is because of the way that the Windows versus the Linux systems end their lines within the files. X11 is part of the Unix Linux environment, and it does allow for GUI so that you can run GUIs within those. Again, there will be examples of this later on within the further systems. So in Windows, the MOBA-Xterm, which is the program the better program to probably use, has X11 utilized within it so that you can tunnel that and use the GUI system of the Linux and Unix environment within it. So down here, we have an example of a GUI editor, the Emacs. When you work a shell script, there's typically kind of a workflow to creating one. You want to write the script in a text editor. Then Then you need to make the script executable through the file permissions. And then the last one is you can run your script. So a bit of when you're writing your first shell script here, lines that begin with the hashtag are usually interpreted as comments. There is one important exception to this, and that's typically the first line of the shell script. The hashtag and the exclamation point tells the OS what interpreter to run the shell script within, and there are multiple different types. So there's a few types listed here, like Bourne, so Bash, Python, and Perl. That first command line here is listed for each of those. To execute a Unix/Linux command from a shell script, you just enter the command on a new line within your script. And as I mentioned earlier, echo is used to print text to the screen. In this case, echo hello world. Here we can see an example of writing a shell script and just typing it out. We have that first first line there. That's very important of to tell it what editor, what to use for and then here we can see this shell script example that we typed up in the first part being ran. So we can see that my first shell script is listed there. And we have to change the permission on it using the chmod. And then once we do that, we can run this shell script, and then we can see its output here, where it's got the text that we told it to print, as well as the date that we asked it to, the date command that we asked it to print out. So the chmod plus x, and then the name of your script. This modifies the permissions on the file, and it makes it executable. If you don't change your permissions, you can't. You aren't able to run your script. It won't. It's because it's not executable. Therefore, the OS doesn't know to execute this the script as a bash script. In the command line, there are a couple of options to look at what's within a file. Cat and less are typical commands that you use to view the file contents. Cat will just print the entire contents of the file to the screen, which can be a little bit busy, or because if you have a file that has a lot of text within it. Less puts you into basically a interface that allows you to scroll through the contents within the file. Here we can see a couple of examples of using both cat on our shell script that we created before and the less. So the first one, cat, it just prints it to the screen. And then here, when we use less, you can see that it gives us the option to view the contents within the file. And when you're using less, if you want, you can use the space bar to scroll through the content, very similar to the manual pages that we talked about in the Compute 101. And then you also utilize the Q to quit out of the view. So within the using bash, and because we talked about the changing the permissions to your script so that it can be executable, we'll go over a bit of the file directory and permissions. We mentioned in Compute 101 that the command ls-lh returns the details of all the files and directories within the current directory. And part of this information is the permissions that are of each file, which you can see at the beginning there, with the R, W, and X and the dashes. All of those are the listed permissions. So the very first, the D or the dash within this tells you whether or not it's a file or a directory. A dash means a file, a D means a directory. And then for following that are the permissions for 3 different sets of groups. The first set is what the owner of the file is able to do with this file. The second is what the group the owner of the file is part of is able to do. And the third is what anyone can do with this file. So a user that may not have created this file or has access to it through other means. The permission codes are R for read, W for write, and X for executable. If you were to look at a file that only the owner can read, write, and execute, it would look as the example here with a dash W or RWX and then a 6 further dashes each. The middle 3 or the first 3 dashes is for the group permissions, and then the last 3 dashes are for the permissions for everyone. So basically only the owner of this file would have access to this file. if you wanted an example, if you wanted to give, have a file that had the permissions to the group, an example is here where we have the RWX for the owner and then RW dash for the group, which means that the group can read and write on this file, but they can't execute it. And then if you wanted other people to be able to read this file, but not modify it or execute it so that they can see what's there, but not do anything with it, you would have example here, like here, where we have R dash dash, which means read, and then no write or execute. So before we've talked about using the chmod command to make our script executable. This same command can be used to change any of the permissions of a file or directory. And to do so, there is a number system associated with those permissions. So read is 4, write is 2, and executable is 1. Therefore, in this system, 4 means read only, 6 would mean read and write, and 7 would mean all 3. So if we want to change the permissions of a file so that only the owner can read and write, we would have chmod and then 600. So the first number is for the owner, the second number is for the group, and the third number is for the everyone. If we wanted it so that the owner and the group can both read and write, the number would be 660. And then an example for the owner and the group to read and write, and then everyone else can see it. It would be 664. To run a script, you need to enter the path to the script. And so you can run the script via the absolute path or using the home alias. So in this case, the absolute path would be home, username, and then my script, or the tilde my script. And if your script is within the directory or you're currently working in your working directory, you can use / to indicate use this current directory and be able to execute your script that way. Some additional concepts within a shell script is there's variables, conditionals, and loops that you can utilize within a shell script. And in shell scripts, as well as in the Linux Unix environment, the variables are typically defined using all capital letters. And then once you've defined a variable, you can use the $sign in front of it to basically utilize that variable within commands. So in this case, we're creating a variable called my variable. And then that variable is a string of text that is, this is my variable. So down here on the example, we create the variable and then we use echo with the variable to echo the string of text that it represents. This becomes useful within shell scripts because you can, if you have a file or directory that you want to reference multiple times, you can create a shorter variable name for that path to that file so that you don't have to type out a long path name every time. So in this case, the example is we created the variable my long path, and then here we have a path name that's not too long, but it's they can be longer. And so once we have that, anytime we want to use that full path name, we can just utilize the variable instead. Conditionals are where different actions are taken with dependent on whether a certain condition is met or not, and you can use these within your shell script as well. Typical conditional is an if then statement. In this case, we start with our normal bash script, And then here, T1 and T2 are two variables we defined. So T1 is a variable with a value of 5, T2 is a variable with a value of 7. And then our if statement here is if the first variable, so T1 is equal to T2, then you echo out the expression is evaluated as true. Here we use else. If it's not true, then we echo out the text expression is evaluated as false. And then phi here is to end this if else statement, the end of that. So here we can see that we have that as within a shell script called conditionals.sh. And when we have all that text there, you can see it, and then we run the command. And in this case, since 5 is not equal to 7, it gives us the output of expression evaluated as false. One thing to note is that Bash is picky about white spaces, so that if you don't have the correct white spaces, your script may not behave properly while you're creating the file when you go to execute the file. And third example, the next example here for within shell scripts is our loops. And that basically what a loop executes a command over and over until a specified amount of times or until a certain condition is met. If you have a defined set of values, you would utilize a for loop. If you need the loop to continue until a specified condition is no longer valid or is met, you would use a while loop. So the example here we use is that is a while loop that runs while the counter is less than 10. And while it's running, it simply echoes the value of the counter. So in this case, we have while, and then the counter, and then -LT means less than 10. So we're telling it that while this is a condition to do what we tell it, the commands we have here. And so the commands here that we're telling it to do while this is the case is to echo the counter we have, and then we're telling it to increase the counter's value by 1. So down here we can see an example of it doing this. So we have our while loop, and then we have here, and then while it's doing it, it echoes out 0 through 9, and then quits, because once it's reached 10, the while loop up here is no longer valid, and so it exits out of the loop. And then for loops iterates on a value. In this case, we're using a for loop to iterate on a value of I, which is a variable of 1 through 5. And then we're telling it within this loop that for each of these values for I to echo the phrase welcome, and then the value times. Down here, you can see the example of that. To the for loop, it's the same one we have above, and then here